Robot Talk is the podcast that sits down with robot enthusiasts from around the world and asks them the questions you always wanted answered. Like, is that drone delivering medicine? And how does that thing work? Hello everyone, welcome to Robot Talk. I'm your host, Claire Asher, and this week I'm finding out about the new era of drone deliveries. From transporting vital medicines to dropping off your groceries. But first, I'd like to remind you to rate this episode and leave a review if that's something you can do on the platform you're listening on. And don't forget to share the podcast on social media or tell your friends about it. It really helps the podcast reach more listeners. So, without further ado, I'm excited to introduce this week's guest. I recently had a great chat with Keenan Wyrobek from Zipline about drones for delivering life-saving medicine to hard-to-reach locations. Today, I'm talking to Keenan Wyrobek, co-founder of Zipline, the world's first drone delivery service focused on delivering life-saving medicine to remote locations. Hi Keenan, wonderful to have you on Robot Talk.
It's great to be with you.
So you co-founded Zipline 10 years ago. What initially inspired you to take on this challenge?
So I spent the 7 years before Zipline starting and scaling ROS. So this was Robot Operating System is it's taken off in the robotics community, as I think most of your listeners are probably aware. Started as my grad student project, me and my partner, and spent 7 years getting the funding for that and really making that go. And that really gave me the itch of, like, as a roboticist, not being focused on the robot piece, but instead focused on like what people actually need piece. And so I knew the next thing I wanted to do it that way. I wanted to find a problem I wanted to solve, and then think about whether there was a technology solution for it. And at that time, Amazon had announced drone delivery coming next year. This was 10 years ago. And my wife's an epidemiologist. My now co-founder's family is also in public health. And we kept hearing from them about how these big health intervention campaigns, like a vaccine campaign, fails on logistics, right? They have the supplies, they have the doctors, they have everything ready to go, but they can't keep the vaccines refrigerated or frozen. Yeah. They can't get them where they are needed in time, and the campaign fails. And so, being the skeptic, I was like, cool, we're going to go look and find all the 1,000 reasons why we can't do this. Like, there's no way to solve this problem. But the more time we spent in the field really understanding this problem, the more conviction we had that we could solve it, and we went for it.
Amazing. Yeah, I mean, it's a huge kind of adventure to start your own company and to kind of really be a pioneer in a field like this.
Yeah, that's an understatement. I think you really have to enjoy adventure. You have to enjoy, if you don't enjoy like one challenge after another, you're not going to enjoy this kind of thing. So I think that's, for those of us who enjoy it, it's the fun of it. Yeah.
Yeah. And was it immediately apparent to you that drones were the way to approach this?
Yeah. There's, in the health vertical, there's obviously a number of sub verticals. And so we could spend the whole podcast just talking about what we've learned in blood or vaccines or these other areas.
Right.
But the thing that ties them all together is basically you don't necessarily know what you're going to need when you're going to need it, right? So the most common use of blood, for example, right, is postpartum hemorrhage. The most common use around the world. About half the blood in the world is used to treat mothers after childbirth.
Yeah.
But you don't know what blood type you're going to need. You don't know how many units you're going to need. And blood has a very strict cold chain requirements to keep it safe. Yeah. It's very rare, and it's also has a very short shelf life. And so the value of being able to keep it in one place and deliver the exact type of blood where it's needed, when it's needed, was just transformational. That was really clear. And it was also clear that like the only magic solution to that was drones. Whether it would work or not, that wasn't clear at the beginning. We thought it would. We thought we should go for it.
Yeah.
But all previous attempts at really making a scalable, economical solution to this, with motorcycles or other transport solutions had fallen flat all around the world. And we had met lots of people who had tried that and had told us of like, hey, you got to try something because everything we've tried doesn't work. And so it gave us the courage to try something that we thought might work, but we didn't know for sure.
Yeah. Well, I'm glad you tried. So can you describe Zipline's Platform 1 drones and tell us about the hardware that kind of underpins all of this?
Yeah, so the drone itself looks like a large remote control airplane. It's not like a quadcopter like we think of as a drone.
Yeah.
It's very much a small plane or a large remote control plane. And it delivers about a cake box size delivery. And it does it by flying out to a delivery site like the yard of a clinic or hospital. And then it releases that package. It has a little paper parachute on it. And it floats to the ground at the delivery site. It turns around, flies back, and gets the next delivery. And we do what I just described about every 65 seconds around the world right now.
That's incredible. So where do these drones live? Where do they sleep when they're not delivering?
Yeah, so we call it the nest, and it's basically our distribution center. So in a country like Rwanda, where we started this service, we have 2 distribution centers there, 2 nests, that cover about 97% of the land area of the country from a service area perspective. And so each one of them has dozens of these zips, our drones. And there's sort of 2 cool pieces of technology that enable this at the distribution center. One is our launching system, which is a supercapacitor-backed electric launcher that takes a zip from 0 to about 110 kilometers per hour in a quarter second. So that zip is flying comfortably, right? There's no, the way we think about it is like, imagine it's really, really stormy and you're launching a zip into a storm. You want to make sure that zip is not like about to take off and maybe going to get smashed in the ground. It's like, no. At the end of that launcher, it is flying. It's way above the stall speed. It's flying really well, and it's on its way to delivery site. And then the crazier thing that's hard to describe verbally is how we land. When the zip comes back, the zip does a flyby. Think of the flyby the way kind of like a touch and go on an aircraft carrier, right? The zip isn't trying to land, it's just trying to do a flyby. And then we have a system we call Snapcatch that has 2 poles that are maybe 4 meters each with a line between them. And those poles pivot and literally flick the line into the tail hook of the plane as it flies by. And this was the answer to the question of how do you repeatably, reliably, and gently recover an aircraft?
Yeah.
Because it turns out when we studied this in the early days, it's like, okay, what determines the life of aircraft, whether they're drones or big aircraft, is hard landings. Once you're in the air, it's relatively straightforward to model everything you need to design for. But it's when you land. If you have hard landings, now you have an unpredictable life of your aircraft, which for us would mean an unpredictable service for our customers. And so basically you can imagine a zip coming in and bouncing around in stormy conditions, and we can kind of pluck it out of the air and very gently, without ever touching the ground, decelerate that aircraft. Anyway, I probably haven't done a very good job of describing it, so maybe check it out on our website. We've got some cool videos.
I mean, I've got a picture in my mind of what you're describing, and it's clear from your description that an awful lot of engineering and trial and error has gone into developing that system.
Absolutely. Where this came from is, right, so the customers in this space, they want long range and low cost. That's the main 2 things they're looking for. And of course, if you're trying to push that hard, you have to use a fixed wing aircraft, right? As opposed to a drone that can hover. Because if, compared to something that can hover, you're going to get something like 8 times more range out of that same size aircraft, same cost of aircraft.
Yeah.
And of course, that's a big X factor, right? Because, that's what these customers are looking for. And so then the question was, okay, how do we deliver? And that's where we have the little cake box with a paper parachute to float it down, because you can't land these at a delivery site. And then the question was, how do you launch and recover them at scale? And that's where our electric launcher and Snapcatch recovery system or landing system came from many, many experiments, iterations of like, okay, we know we need a fixed wing aircraft for the range and the cost. How on earth are we going to reliably launch and land these things while we're doing them, nonstop all day, every day?
Yeah, sure. We have an audience question that was submitted by Hunter on Twitter. So Hunter says, I'd love to know about the logistics and infrastructure needed to make drone deliveries scalable and sustainable in remote areas, and how Zipline is addressing those challenges.
Yeah. So our Platform One system, the way I think about it conceptually is it goes from the outskirts of a metro area and serves like the surrounding cities in the countryside. Um,
Okay.
and so our distribution centers, by definition, they can't be super remote because otherwise we can't reliably get the vaccines, the blood, the pharmaceuticals and other products we deliver from those locations. The honest answer is there's many, many things that we've learned along the way to enable this to scale.
Yeah.
I'll give a couple of examples. Our drones are completely modular, and every module of the drone is independently waterproof.
Okay.
So in the field, if there's a problem, the software, in almost all cases, will tell the operator, hey, I need you to replace this module because it can self-diagnose. And then the operator takes some 5 to 10 minutes to replace the module. And unlike a traditional, waterproof drone system or aircraft where there's like, you better reset that hatch carefully to reset the waterproof seal, otherwise it's going to leak. We've designed that kind of room for error out of the system. And this is one example of both the self-diagnosis and the modules that are independently waterproof of what it takes to make something really hyper scalable, right? Because we do only have a few operators operating at some locations, 30, 40, 50 aircraft at once. And so obviously their time is super valuable and maintenance just can't take very much time. And it certainly can't be error prone because we need them to do the maintenance and we get that aircraft right back into service.
Yeah.
So that's one of many examples. And by the way, even that launcher system I described, the recovery system, it's similarly modular and designed for very fast module swapping in practice. And our teams literally rehearse for that. I think that's one good example of what it takes to make this scalable. Another good example is really the people, right? Our operations in every country we operate in is both staffed by and led by entirely local teams. And now, this is both because the talent in these countries is extraordinary, but also because operating a service like this it's quite complicated how it actually integrates with the health system and the nitty-gritty day-to-day pieces of it, which is both a lot of challenges to work through, which of course people from these communities are motivated to work through this because they're serving their community.
Yeah.
And then, of course, they also have all the context they need to provide great customer service. When there's a customer who's frustrated or a doctor didn't get what they needed, for example, you really want to make sure you're able to quickly establish a rapport and fix the problem for that doctor and get them back to happy and able to treat their patients. And that is something that's been incredibly powerful for our ability to scale around the world.
Yeah, that makes sense. Perhaps it's worth giving the listeners a bit of context about how far you've scaled Zipline so far. So, I mean, how many locations can you say how many zips you've done?
Yeah. So we just reached 1.2 million deliveries. So these are 1.2 million of these flights that we were describing over the years. That's well over 100 million kilometers flown. And so these are significantly long flights. Just to be clear, I think a lot of people, when they picture drone operations, they picture something that can only fly like a few kilometers or something. We fly a long way with these flights. I think there's a lot of fun statistics around that. We obviously started with an obsession around healthcare. Yeah. Today we deliver for other use cases, animal care, animal health. We deliver, hot meals around the world. We deliver all kinds of things, bento boxes in Japan, in addition to healthcare supplies in the island chains there. And there's another sort of aspect of the impact Zipline has that I get incredibly excited about, which is really the environmental impact of this. These drones are phenomenally efficient. They use very, very little electricity. And we think we've saved well over 900,000 gallons of gas, for example, by displacing people driving these things around the way they did before. And of course, we're just getting started. So I mentioned that we're at that 1.2 million deliveries total today. The focus of the company right now is getting to 1 million deliveries per day in 5 years.
That's very ambitious. I like it. And I guess being electric, in principle, that energy can all come from renewables.
Yeah, that's a big part of it for sure. The other part of it, which I think is when you think about like the environmental impact of something, often we focus on, where does the power come from? Is it from gas? Is it from electricity? Is it from renewable electricity? But the other big factor is, of course, like we call the supply chain impact, right? So you had to build that aircraft, you had to build that car. Like, what's the environmental impact of building that? And in sort of simple terms, you can think of it as like, we're basically a very, very efficient electric car, right? We can fly, very long range on a battery pack that's like about 1/100th the size of a battery pack in an electric car. And then we have aircraft now approaching 1 million miles of life on the aircraft. And so you take something that's much smaller, like literally like fewer cells have to be made than for an electric car. And of course, you take it over a much longer life. The multiplication is really impactful in terms of how much smaller of a supply chain impact you're having with these systems, which is also very exciting.
Yeah, absolutely. That's a really important point. So, as if all of this wasn't keeping you busy enough, Zipline also has an entirely new drone platform coming soon, which is going to deliver into more built-up areas and deliver different items like groceries, takeout food, and shopping. So can you describe this new system and how it works?
Yeah, absolutely. So the platform we've been operating for years, right? This is by far and away the best and most efficient and most economical long-range delivery platform for going from a metro to surrounding areas. But all of our customers, including all of our health customers for years, have been saying, okay, we love this, but can you deliver to hospitals and clinics and even patient homes at scale too in the metro area? And our answer has been no, right? Platform one is, as you can probably picture, right, with a cake box size package and a paper parachute, that takes a few parking spots worth of space to deliver into, which, outside of metro areas, you can find that space to deliver, no problem. But in metro areas, you need to be way more precise. And so after years of telling our customers, no, we don't do that, no, we don't do that, no, we don't do that, we started to think to ourselves, okay, is there a product here we actually would want to serve with our customers? Is there a delivery experience that's actually quiet enough and precise enough and economical enough that we'd be excited about it? Because we had seen other people do, drone delivery with like tethers and they're just really noisy, or they're actually not that precise. They still need a lot of space to deliver into. And that's where Platform 2 came from, was a deep dive for a couple of years of some of our strongest engineers, really trying to figure out how could you make something that's actually precise, really precise, like you can deliver to essentially all addresses, outside of the skyscrapers in a metro area. That's Platform 2. So Platform 2, I should describe it. It's a very different platform technologically from Platform 1. The drone for Platform 2 is a hover capable. So it has a wing, but it also has hovering rotors, so it can hover in place. Okay. When it comes out to a delivery site, it will hover. But this is when Platform 2 gets interesting. So Platform 2 is actually two vehicles in one. Nestled in the belly of the drone is a little thing we call a droid that comes down on a tether. And now the first thing I should mention is the zip stays way up high. The drone itself stays way up high, about 100 meters up. And then the droid starts lowering down. And the droid itself is basically its own little robot. It has its own fans and its own little autopilot and sensors. So it can very precisely navigate. So even in really windy, gusty conditions, it still goes right where it wants to go. And it has sensors to avoid things like trees and power lines on the way down, and then place a package and then retract. And that's how the Platform 2 system works. And so this system can serve about 99% of addresses in all the metros we've analyzed. So we're very excited about it.
Yeah, that sounds brilliant. I mean, I've been being promised by the media for decades now that I'm going to get drone deliveries soon. So I'm very excited that you might one day bring this to the UK and deliver something to my house.
Absolutely. I can't wait.
So the first thing that jumps out at me about, the difference of trying to deliver something in an urban area as opposed to, kind of in more remote locations, like we've talked about before, is the regulatory issues and the safety issues around bringing autonomous drones into, skies where there's lots going on, basically. So can you talk a little bit about that?
Yeah, absolutely. Before I jump into that, one thing I'll mention is, so people don't often recognize this, maybe we don't explain it that well, but Platform 2 was born from our health use cases. So like the payload mass, the range, the cost structure, these hard physics trades between range and payload and cost you're trading as you figure out what aircraft system to build. These all came from our health partners. And it turns out by changing one dimension, the width of the payload bay where the package goes, by 1 centimeter wider, it was made it great for delivering hot meals. And so we did that. And then it turns out it's also good for e-commerce and these other things. But we're also doing everything I just mentioned and outside of health, we're also doing on Platform One around the world. So, and then in addition to that, people often picture Platform One as operating, in the middle of nowhere. But it really doesn't. So Platform One, all of our first delivery sites before we started delivering to clinics were all hospitals. And hospitals, by definition, are, they're not in the middle of nowhere. They're built in pretty meaningful cities. So we have a lot of experience with the regulatory challenges of operating in cities. And today we do that in the US here in Arkansas and in Utah. And really fundamentally, it comes down to both having a good solution for maintaining separation with other air traffic, and as well as having a number of safety layers on your system to make sure you're safe for people on the ground as well. Probably one of the coolest pieces of technology that we've developed over the last couple of years that's gotten regulatory approval, got regulatory approval by the FAA, our airspace regulator here in the United States last year, which is our acoustic plus transponder or radio communication based detect and avoid, as it's called in this industry. So what does that mean? It means we listen for other aircraft with an array of microphones. Very similar to how, as a human being, you're walking on the road, you don't see an aircraft first, you usually hear it first. And our aircrafts can do the same. They can hear an aircraft first and basically use that information to maintain separation. This was very exciting. This was the first time our regulator here has ever approved AI-based autonomy for safety in the U.S. airspace. And we operate using that system every day now in 2 states. And that'll be on Platform 2 as well.
Yeah, amazing. I mean, I think, this is something I hear a lot from people I talk to is this challenge of regulatory agencies and policies catching up with new technology that the old regulations were not designed to deal with.
Yeah, every country we operate in, it's been the similar journey. There's no regulation that allows this. And so you have to do it by exception. And that, of course, is a bit of a journey. To work with these regulators. And of course, on the engineering and development side, you want to do this anyway, of course, but you have to do very rigorous testing and documentation so that when you go to the regulator, you have the case you need to have to say we're ready to go. And this is why it's safe enough. And this is why, you should take that bet on us. And we've made progress now in countries around the world, but we still have a lot of progress ahead of us.
Yeah, sure. So what's next? What do you hope to achieve in the next 5 to 10 years?
Yeah. Let me get a little wonky on the health side for 1 second part of answering this question, because this is one of the things that gets me so excited. So when we started with Zipline, we started just delivering blood to hospitals. Now we do many other things. And blood to hospitals is probably the most extreme example of an acute care solution, right? It's something that if you, right now, or else it gets life-threatening. And then, of course, the very other end of the spectrum is preventative care, right? And part of the reason our health partners around the world have been asking for more delivery to homes and more delivery in metro areas is because they know something that's sort of universally well understood in healthcare systems, which is if you want to increase the quality of healthcare in a broad-based way while reducing the cost of healthcare in a broad-based way, the only way to do that is through preventative care. Almost every single other intervention that improves quality of healthcare increases cost. And there's just very few things that actually increase quality while reducing cost. And this is something I'm just extraordinarily excited about with both Platform 1 and Platform 2, is getting everybody what they need to adhere to their healthcare regime, no matter what their situation is. And we saw this in the early days. The first home deliveries we were doing in Africa were to patient homes, to patients who are HIV positive of antiretroviral medications. If you're not familiar, antiretroviral medications have come a long way in the last 20 years. Like if you stay on them now, you can live a long, healthy life. But if you go off them, you can end up in a hospital within weeks. And so now you have aging populations who are HIV positive and need to stay on these medications. And these health systems are struggling with the basics of just making sure they're reliably getting the medication they need to stay out of the hospital. Again, be healthier at lower costs to the health system. And of course, there's so many other examples like this that are just so simple, like hypertension medication, right? And so many of the things that I'm excited about with what we can do with both Platform 1 and Platform 2 is enable these very new models of preventative care, healthcare in the home, where not only can we get you the medication you need, but we can be the physical side of a telehealth visit, so you can get what you need without ever leaving your house in many situations. Many health systems around the world have traveling practitioners. We have contracts here in the US with something like a dozen US health systems. And almost every single one of those contracts has a component to support traveling practitioners. So a nurse who comes to your house, we work with them. And half the time they come to your house, they see a need for something, for some supply they didn't anticipate. And we want to deliver while they're still there. And they can take care of it, nice and easy. And this kind of supporting this kind of very unglamorous thing of preventative healthcare is something that I'm just very excited about, because, this country here, we set the record in terms of our spend on healthcare per capita worldwide, which is not something we should be proud of. And but we have the same challenge that Rwanda has, which is how do you increase the quality of care while reducing costs? And we can play a really big role in that. And we've shown we can with some of the big impacts we've made around the world. So this is what I'm excited about for the next 5 to 10 years. One of the things. Yeah,
absolutely. I mean, this is incredibly impactful work, as well as being like really quite cool engineering. So it's great to hear about it, and I really appreciate your time. Keenan, it's been great chatting to you today. I've been speaking to Keenan Wyrobek from Zipline. Thank you.
Real pleasure.
Thanks for listening. If you enjoy Robot Talk, please share the podcast, subscribe, and leave a review. It really helps boost the podcast, so thanks in advance. And don't forget to join the Robot Talk community on Patreon if you'd like to support the podcast and get access to some awesome perks, including behind-the-scenes updates and monthly bonus episodes. Visit patreon.com/Claire Asher to find out more. Robot Talk will be taking a break over the holidays, but I'll be back in January with more fascinating guests and awesome robots. In 3 weeks' time, I'll be speaking to Kirsten Peterson from Cornell University about robot swarms inspired by nature. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk is brought to you by the Hamlin Centre, Imperial College London.